Ladies and gentlemen, please welcome Richard Waymire.
Good morning. Is it too early for all of you? It's way too early for me. So let's talk about security enhancements in SQL Server 2000. We've done a number of things to make SQL Server much more secure. I'll give you a typical example of the kind of thing we're going to talk about today. There are probably a number of you in the audience who read that MSNBC story about people getting other people's credit cards on the internet. And the way they got them was by logging into somebody's SQL server with SA no password. Somebody put their SQL server on the internet with SA no password. Now you have to ask yourself, what were they thinking? But of course they probably weren't, or they wouldn't have had SA no password. So in SQL Server 2000, we will set up in integrated security mode by default. And if you do want to go to mixed, you have to change the password. No more SA, no password on the internet. We're going to try and fix that one. So a number of things like that to just make the system secure. This represents a pretty significant philosophical change for the SQL Server team. Instead of giving you a system and letting you lock it down, which NT's kind of like that. SQL Server, at least from the login perspective, was like that. We're going to go the opposite way. When you install SQL Server, it's locked down, and if you want to open it up, you can do that. But we're going to lock it down by default now. So it's not our fault anymore. Okay, so we're going to talk about a quick overview of SQL 7 security, which is also going to be at least a little bit an overview of SQL 2000 security. I want to talk about auditing and what we've done to enable auditing in SQL Server 2000. I want to talk about some more of those details on the setup enhancements. Networking improvements. So what have we done to enhance networking security in SQL Server 2000? We've added a role, and we've done some other things that I think you'll really like with our server roles. There are a lot of miscellaneous little enhancements to do with security. And finally, I just want to make a couple comments about our C2 evaluation that's ongoing. Here's that slide again. You know what it means. We're on SQL Server here. So let's talk about SQL 7 security. Our basic model of how you connect to a SQL Server has not changed between SQL Server 7 and SQL Server 2000. First thing you got to do is connect to the SQL Server computer. When you do that, we have to find the computer on the network. You have to do an initial handshake that says, I want to connect to this server. Is that okay with you? And in SQL Server 2000, there's some additional stuff that we'll talk about later going on in the form of a network handshake. Then you have to log into SQL Server. You either have to present your standard security credentials to SQL Server, and of course then SQL Server would look it up in the sysx logins table, take your password, one-way encrypt it, compare it to the one-way encrypted password we store in sysx logins, and allow you in. That's what we'd call standard security mode or SQL Server authentication mode. Or when you connect, you'll request Windows NT or Windows 2000 authentication. We call the SSPI interface back, which is the Security Support Provider interface of Windows. We call back into the operating system and say, here's this blob this user handed us. Is this really whoever they presented themselves as being? Is this really Redmond R. Waymire that tried to connect to me? And then Windows will say yes, and oh, by the way, here's his SID, and here's all the SIDs he's associated with, the security identifiers of every group I'm a member of. And of course, my unique identifier on the network. The first thing you do when you connect after establishing your login credentials is switch to a database. Even if you're switching to master, you're still switching to a database inside of SQL Server. And you have to be authorized to use that database. Most people just sort of default into master. The only reason that works is because we have a guest account that's mandatory in master. Because otherwise what would happen is you'd log in and then you couldn't switch anywhere, so you couldn't actually do anything. It'd be pretty boring. So you can get into master. If you try to switch to another database like pubs, we'll look for a username there. And again, just like in SQL Server 7, we'll look for your NT username, any NT group you're a member of, or if you're a SQL Server standard security login, we'll look for a mapping between a username in the database and your login name in SQL Server. And finally, you attempt to perform some operation. For instance, select star from pubs.authors. When you do that, we verify that you have the right to do that operation. In this case, select on all columns of the authors table. So whatever you try and do, we'll validate that operation. I've already kind of mentioned it. There are two modes for SQL Server security. Integrated security mode, which you'll, in the SQL Server 2000 books online, we're switching our terminology again. We're now going to be calling it Windows Authentication Mode, because we had Windows NT authentication before, but now with Windows 2000 we wanted to find a more generic term. So it's Windows Authentication Mode, or Integrated Security Mode. I can't help it, I've been calling it that for 5 years. It only accepts logins using your Windows NT or Windows 2000 security credentials. What this does for you is implement a Windows DNA single sign-on. I log into the network once, no matter where I go, what I do, I am Redmond Waymire. Anywhere in the Microsoft enterprise, in your company, you'd be whoever you are, your network credentials are, everywhere. A lot of customers are still using mixed security mode because I haven't sufficiently browbeaten you into getting off of it. At some point, we will be dropping mixed security mode. We're not kidding about that. So you need to be migrating to integrated security mode. In mixed security mode, we allow integrated logins from Windows. We also will still allow SQL Server-based security logins, where you go into SQL Server and define a new user and say, hey, this is user Joe, and Joe has some password. And it's totally controlled by the SQL Server administrator without necessarily having any rights in the operating system. There are a bunch of issues with using mixed security mode over integrated, not the least of which is we have deliberately chosen not to do things like provide strong password requirements, not to provide minimum password lengths, not to provide mandatory changes of your password, all those things. And the reason we haven't done that is because Windows 2000 and NT4 do that perfectly fine, and you should be using integrated security mode. As you are probably aware of, they've had their share of having to do hot fixes and patches and resecuring their security database one time after another. And we're really glad that it's them and not us that are doing that, because we don't want to get in the business of having to do all of the right things to make your network secure. We think you should use Windows to do that. And we want you to do that by using integrated security mode. But if you insist, you can still come in with a standard security login. Just like in SQL Server 7, there is no such thing as standard security mode anymore. You're either in integrated only or mixed, which allows both. The only way you could ever truly turn off integrated security is to go in to the SQL Server Enterprise Manager and delete all of the integrated logins. At that point, nobody's allowed in. The problem with doing that is that if you forget your SA password, you get to reinstall. There is no hack. I saw somebody had published a vulnerability, as they called it, where they could shut down SQL Server, they could crash it, and then go in at a certain byte offset and master and replace the encrypted text of the SA password. And they were trying to say, this isn't a security hole. Well, maybe it is, but maybe it isn't. Maybe it's a way for you to fix your SA password. The only problem is the location for the SA password is not fixed. And it changes from install to install and release to release. So if you happen to go in there and try this, you may overwrite, say, the master control block, and so you can't start SQL Server anymore. So be very paranoid if you're going to go out and play with utilities like that. By the way, there was, in fact, a vulnerability in SQL 7 that many people have published where you could send random garbage to our TCP port and the SQL Server would crash. We fixed that with Service Pack 2, which should be out next week. Fingers are crossed. So you'll want to apply SP2 to make sure that you're completely safe against anybody attacking your TCP ports directly. Probably not a big concern on your intranet. It's probably a big deal if you're going to expose SQL Server on the internet. Just like in SQL Server 7, we have fixed server roles. There used to be 7, there's more now. And what they allow you to do is subdivide the permissions an administrator can have. So I don't have to be the system administrator of SQL Server to do things like add a new login or create a database anymore. I can be in one of these subservient roles and get my job done without having to have complete and total control of SQL Server. We have a sort of a mirrored concept in the database level with fixed database roles. Fixed database roles will allow you to do things like, I want to be a backup operator so I can back up the database. I want to be a security admin so I can add new users to the database and control permissions. Things like that are still available. Those really haven't changed between SQL 7 and SQL 2000. Flexible database roles are still there. You can add your own roles. You can put users or NT groups into your own roles and mix and match as you please for any sort of custom security combination. And application roles are there, so you can enable an application role from an application, and then you lose the context of security of the user you're currently logged in as and become the application role. So any permissions assigned to the application role are used instead of the permissions that are assigned to your individual user account, and that is protected with a password as well. SQL Server has 3 permissions verbs in SQL 7 and SQL 2000. We have a grant, which explicitly gives you a right. So if I issue a grant, I get a positive permission. I can do a deny, which says, no way, you're not getting in. And that's a negative permission. And then I have a revoke, and a revoke is a deletion of a grant or a deny. The way I think of this is in terms of the system tables to make it easier for me. If I do a grant, I put a row in a table that says you can do this. If I do a deny, I put a row in a table that says you can't do this. If I revoke, I'm deleting one of those rows. So if I revoke a permission you don't have, it doesn't do anything. It's a no-op. Denies always win. So, first lesson, never, ever, ever deny to public. Because everybody's in public. So you just said no one can ever use this, so why did you bother creating it? So what you want to do is grant to groups and deny individuals, particularly if they didn't put more coffee in the coffee pot when you went to get a cup. It happens all the time at the office. Okay, security auditing enhancements. What did we do for auditing now in SQL Server 2000? We've sort of had, we'll call it an audit feature, in SQL Server 7. We audited successful or failed login attempts, and the way we did that was via a registry key, and then we put entries in your Windows event log. So a couple of events I put here on the slide deck. Event 18453 was login succeeded for whoever, Redmond or Waymire, connection is trusted in this case. And 18456 was login failed for user, and then in this case I used a standard security user of Richard. So you'd see these out in your NT event log under the application entry of the event log. And you configured this via Enterprise Manager, which again simply set a registry key that was, I want to configure all successful logins, all failed logins, or both. So not a lot of granularity. You could use Profiler to audit SQL Server by capturing all the SQL Server statements. However, the performance overhead can be quite high in capturing all the text of SQL statements. You don't necessarily capture denied events in Profiler. So if I tried to access a table and I didn't get access, there was no record written because Profiler in SQL Server 7 was not meant to be an audit tool. And there's no guarantee of 100% audit capabilities. What I mean by that is, let's say the server was extraordinarily busy. All the CPUs are spiked. If your Profiler utility can't keep up with all the events being generated, it will skip some in favor of allowing your ordinary workload to continue on the assumption that your workload was more important than the Profiler trace. So for that reason, you cannot use this as a true audit utility. And the truth is, we never designed it as an audit utility. It was meant to be a helpful thing to help you find what T-SQL is going, to help you with the index tuning wizard, to help you profile and tune applications, not as a security tool. So as part of our C2 effort, and as a general strengthening of our security features in the product, we wanted to add auditing. And we really, really like Profiler. It's easy to use, it's easy to figure out, and it makes a lot of sense. But as I just said, there were some limitations in the SQL 7 implementation that we couldn't live with. So we broke up Profiler into 2 logical components. There's a component called SQL Trace, which is the server side of profiling. And then there's the SQL Server Profiler, which now, when we talk about Profiler, we're talking about the user interface. When we talk about SQL Trace, we're talking about the server-side implementation inside of the relational engine and the storage engine, where we produce events and then pass them back either to a file or to the Profiler UI. And we threw out the old implementation between beta 1 and beta 2 and started from scratch. So everything you knew about Profiler, I hope you didn't learn all those XPs, because you don't need them anymore. They don't exist. A couple of things we've added to make auditing much more attractive in SQL Server 2000. We support file rollover. What I mean by that is I start auditing and I fill up a trace file. And let's say at 500 megabytes, I want to be able to take that file offline and back it up to tape and get it off my server so I can get the next one. When you configure auditing, you can say, or actually now any profiler trace, I could say, oh, at 500 megabytes, stop with this file, open a new file, put a sequential sequence number on it so that I know it's the next file, and close the previous file. And we'll just keep doing that forever. So every 500 meg will stop, create a new file, and you can copy those old files off to backup or whatever else, and thus keep a continuous log of your production activity. You can specify a maximum file size. You can say, I want to create a trace, but only until it's 1 gigabyte in size, and then just stop doing that. Or you can say, I want to run a trace until 8 o'clock tonight. So a number of enhancements, we hope. We have a black box option, and we're going to do some performance measurements and figure out whether we'll just leave this thing on all the time. Essentially what it does is capture the last small amount of work that's been happening on your machine, so that if you crash, we'll have a profiler trace when you call product support, and we'll know what crashed your system. So we're looking at what the impact would be of having that on all the time. If it's unacceptable on our stress testing, what we'll do is tell you how to turn it on if you're willing to live with the hit and not ship it by default. We still don't know what we're going to do there. But again, that way, if you call product support, you don't have to say, well, somebody was making a joke the other day. They said Bill Gates called the police over in Europe and when he got hit with the cream pie, and they said, sir, could you do me a favor and step out of the door for a moment and then walk back in? Comes back to the phone, they say, did you get hit with the cream pie again? And he says, no. And he said, okay, that's not reproducible, so we're not going to file a bug on that. Well, we don't want that to happen to you with SQL Server, so we want to have this trace out there so we know what happened, you know what happened, and we can try and reproduce it. This isn't really part of auditing per se, it's more a support tool, but we want to make it available to you. There are a number of new events to trace in SQL Server 2000, all of which are related to auditing. 18 different kinds of audit events. Every time you log in or log out, we can record an audit record. A grant, revoke, or deny of a statement permission. A grant, revoke, or deny of an object permission. Anytime you add or drop a standard security login. Anytime you grant, revoke, or deny NT logins for either an individual NT user or an NT group. Modify a login property, so if you set the default database or the default language, something like that, we'll capture that. If you change your password on a standard security account, we'll capture that. Add or remove anybody from a fixed server role, add or remove anybody from a database, add or remove a database role member, a database role itself, change the app role password, use a statement permission, which is anytime I issue, say, a create table or a create database. An object permission, a select, insert, update, delete references, will capture all those. Backup, restore events, anytime I have a backup or restore run, we could create an audit log of that. Any DBCC command, so if you want to find out all those hidden tools that Enterprise Manager is using, you can capture all the DBCC events. Audit modification event, anytime somebody messes with your audit trace, we'll audit that. And server shutdown, server pause, or server start will all be audited in our trace files, if you want to turn them on. All of these are optional. For each event, we have many, many subtypes depending on the type of event you're producing. For example, in grant, revoke, deny of an object permission, first of all, the event could be a grant, the event could be a revoke, the event could be a deny, and within that, we have to tell you whether it was a success or a failure of the permissions attempt. We do not audit whether the statement succeeded, only whether the permissions check succeeded or failed. So they're completely different operations inside of SQL Server. We record the server name that we're running on, the date and time that the event started. We don't record the end time, we record the start time, so when the statement was received at the server. The application that you were running on your client, if we can get it. The NT username of the user on the client, even if you didn't tell us, we'll try and figure it out and audit it. The security ID, the SPID that you're running inside of SQL Server, the process ID. The host name of the computer that submitted the SQL query, and optionally, depending on what kind of statement, the statement text. That's why I've got a little star there. For some events, we produce the text of the statement. For some, we don't. If we can audit everything about a statement without having to give you the text, it'll keep a much smaller audit file, so we don't give it to you unless we have to. How do you turn on an audit? An audit, except for a C2 audit, I'm going to talk about C2 auditing in a minute because it's just a whole different ballgame than normal audits, is just a profiler trace, or a SQL trace. Too many words there. So to turn it on, you just start up profiler and configure events and add auditing events. We're just now changing the name over from audit to security audit. So in the UI for beta 2, it should say security audit. You expand that and you'll see all the audit events. So when you set the trace to start with the server, you can get a comprehensive audit. So wrap your trace setup in a stored proc and then enable that stored proc for auto start. So I've got a code example, the beginning of which is up here. So I can say create proc p audit trace with encryption. I figured you'd want to encrypt these so that nobody can decrypt them and look at the text. And then you run all of the statements to turn that on. And then you'd run sp-proc option for whatever your procedure is and set it to startup. Now I've got a detailed code example over here on my laptop that I want to show you. So basically, I've got the procedure p audit trace that I create with encryption. I declare a trace ID variable because the server will assign it a trace ID when it's created. Then I'm going to execute sp-trace create, which is the new stored procedure to create a trace. I need to tell it the trace number. Actually, it's going to tell me the trace number. I have to give it an option set, which is actually a bit mask, but you just set an integer value for. Roll over the file, which says at whatever size I tell you to, do that file rollover thing. That's value 2. Shut down the server if the audit can't write to disk for some reason. So if for any reason we get an I/O error, the hard drive's full, whatever, I want to shut down SQL Server rather than lose any audit records. We'll do that for you. And be careful, that's any reason we have a problem writing that file. We will shut down SQL Server, and you cannot restart it until we can write again, unless you start it in -F or the minimal mode. If you're in minimal mode, we'll bypass startup stored procedures and even C2 auditing if you've got that turned on, so that you can go in and do repairs or whatever else. Then in Unicode, it's very, very important that this be in Unicode. You pass in the path that you want the trace file to be. Now, on the end of it, I'm not putting the .trc extension of a SQL Server trace. The server will add that for you. So the first file would be myaudit.trace. When it rolls over, it would be myaudit_1.trace. The next one _2, etc. And then I said, configure this for 500 megabytes. Now, the text of this stored procedure is going to be on your handouts from the conference on the DVD. So you can use this as an example of writing your own audit traces. So what I did in here is I documented what the valid events are. And I'm going to audit 2 or 3 events in this thing. I'm going to audit a login events. And I know I'm going to audit, I want to say statement permissions. And also, I think backup and restore. I'll show you in a second here. And then for each event class that you want to add to a trace, you have to tell us which columns you want to capture. So this is going to involve a number of repeated calls to stored procedures. It's a little bit painful, as you'll see in a second here. So I want to capture login and logout, backup and restore, and object permissions. So I do an sp-trace set event, which is the new stored procedure to add an event. I pass it the trace number, which event I want to capture, 101. I want to turn the event class column on, and yes, I really want to turn it on. And then I just call it repeatedly for every column that I want to see for that trace. Then I want to add backup and restore, same deal. I turn on backup and restore, and then all the columns that I want to see show up in Profiler or in my audit trace. And finally, I want to look at object permissions. And again, lots of these calls to set event to set this up. And then I documented what the output's going to be. If you translate this on the results, you're going to see, for instance, on a select permission, if I select all the columns, it's going to be a value of 1. If I do an insert, it's a value of 8. And so you'll see that come out on the audit trace. Now, if we wanted to, we could even set filters on this. This is extraordinarily powerful, just like Profiler. I could say only audit records for Chris because I don't trust Chris anymore. Picking on a guy here in the audience. So, or I could trace on only this database or whatever I want to filter on. It's fully capable here, and I included a couple of sample filters that I'm not going to bother turning on right now. And then the last line of the stored procedure says turn the trace on, set status to 1, which is on. So now I'm going to run this create statement and create the stored procedure. Okay, so I created the stored proc. Now, if I wanted to mark it startup so that it would start every time SQL Server would run, I could just run this proc option and set it to start it. Well, I really don't want this audit trace always running on my laptop, so I'm not going to do that now, but it would work fine. Start the trace. And I forgot to do that, so. Okay, start the trace, exec P audit trace. That'll start the profiler trace. Now we've added some user-defined functions to the server to give you information about running traces. So I could say, I want to find all the traces that are running. Select star from : fn trace get info, which is a function called trace get info that we provide. If you pass null, it says, tell me about all traces that are running. And oh boy, it says none are running. So let's try it again. So it's not working. It worked a few minutes ago. This is not very fair. So let's just do one quick check. I swear I got up at 5:45 and verified this worked for you. Let's delete the existing file and see if that's the problem. Yep, okay, so now it's running. Doesn't complain very well yet. We're still working on the error messages to let you know something went wrong. Okay, so I have a trace running, and it tells me a little bit about the trace here. I could find the events that are being captured. Now, I don't have at trace ID declared anymore because I didn't run this thing as all one giant script, but I know it's trace 1 from what you see on the screen. So I can say, tell me which columns were added for which events. And again, this is returned as an ordinary row set. We're using the table data type back from the function. And then if I wanted to check, I could check for any filters. I know I didn't set any, so I didn't bother. Now I could do some audited commands that I know I've just configured for auditing. So I'm going to add a new login called Joe, switch to pubs and add a user called Joe, and then grant a select statement permission to Joe. Okay, so that ran. Now I'm going to stop the trace. Now, in fact, I know that I've got trace ID number 1, so I'm going to replace that up here. What a stop of a trace does is it pauses it. So just like in the old profiler UI, you could say pause and then restart a trace. If you stop it, that's what it does. It pauses the trace, but the server still knows all about the trace. When I run the next statement, which says close the trace, it says, I'm not going to run this anymore, forget all about it, and close the file that you were using. So now I've got this trace closed. I go out to my audit file and I see my trace file. And that's pretty funny. Tried to start the wrong application with it. Don't want to run network monitor. So we'll go ahead and start up SQL Server Profiler. And I'm going to say File, Open, the trace file. Oops. And it's on D, Program Files, Microsoft SQL Server, SQL 2000, Audit. And it opened up the trace that was in there because I double-clicked too many times. And what you'll see here is we started the trace and we recorded that. Then there was that grant. We granted a select on authors to Joe. We see that was in database number 5. You see that that came from computer rwaymire0, which is the name of my laptop. I was username rwaymire on the network. I was using Query Analyzer when I did that. The SPID that I was running under was 51. I started that at 8:01 according to my laptop because it's still on Seattle time. The permission used was number 1, and we could go look at that up in the bitmap and see that that was a whatever kind of grant we issued. This was an event subclass of 1, which was a grant. A 2 might be a revoke. A 3 might be a deny. Again, you have to go look that up. And as it was success. In other words, the permissions check succeeded. I had the right to grant whatever permission I wanted to give to Joe. If it had failed, if I didn't have permission to run this statement, I would have a 0 here. And over here you see it was a the database name was pubs, and again there's the server name, and notice it includes the instance name that I was running on. So that's our trace mechanism for auditing, and you can build that up as big as you want to. You can do as many things as you want with this, configure as little or as much as you want, and you can mix and match audit traces. Let me see. So I don't want to do that. Let me close this. File, new, trace. And I could set a trace here, and under events you'll see security audit, and then there's all the audit events, and you can see that they're just ordinary events like everything else, and I could add the columns, whatever I want to do here. So we've just integrated it in with Profiler, and it just works. Okay, let's go ahead and go back to the PowerPoint here. C2 auditing is a little bit different than what I just showed you. That auditing will work fine, we believe, for the vast majority of corporate customers. It does not have the issues I talked about in SQL 7 with losing records. One of the things we did is absolutely guarantee you will never, ever, ever lose an audit record. Why? Because the government made us, because of C2. In C2 style auditing, we have a few additional parameters we check to turn on auditing. First of all, you must record the audit trace in an NTFS partition. Now in a C2 configuration, you have to be all NTFS anyway, so that shouldn't be any big deal. Every single audit event and every single data column is audited. You have no choice in the matter. If we can't write to the audit log for any reason, we will shut down the server and we will not allow it to start until we can audit. Again, you can bypass that with -F. The rollover size is fixed at 200 megabytes. We will fill up a file to 200 meg, then start a new one, and you cannot change that. The directory it goes into is your MS SQL data directory. You cannot change that. And it's named audit YYYY, so 2000, 03, 04, 08, 05, 01, AM, _1, _2, whatever. Now, why all these restrictions? Because we made it really simple to turn it on or off. SP configure C2 audit mode on, or 1, go. And the next time you start SQL Server, you're in C2 audit mode, and everything you ever attempt to do, success or failed, will be audited. So very, very trivial to turn on. We did this implementation as part of our C2 effort on the evaluation of SQL Server 2000. I'll talk about that a little bit later on. So if you want to capture absolutely everything, there is a shortcut, and it's built into the server. So that's our audit mechanism now in SQL Server 2000. Let's talk about setup enhancements. I already mentioned some at the beginning of the talk. Setup is secure out of the box now, but obviously if you're on Windows 98 or Windows Me, you probably don't care a whole lot about security. If you care about security, you're going to be running NT4 or Windows 2000. So, first of all, we expect you to be installing into an NTFS file system. If you install into an NTFS file system, what we do is we lock down the permissions on all the directories from MS SQL on down. All the files, all the directories. What we set the permissions to are administrators, full control, and the service accounts you select during setup, full control. And nobody else has any permissions to those files or directories anymore. That's it. We do the same thing to the SQL Server registry keys on NT or Windows 2000. All of the SQL Server related registry keys are locked down that are server-side registry keys. We don't lock down client-side keys. Otherwise, you'd have to be an administrator to start Query Analyzer or something. But we lock down all the server-related keys so that nobody can get to them except the service accounts and local administrators. We default to integrated security mode in SQL Server 2000. What we've got is a new security dialog. And let me see. I know you guys don't like demos I haven't tried out, but we'll give something a shot here. I'm going to try and install another named instance over here on my middle computer. Thank you. And let me get my SQL Server CD going. And I'll show you this new security dialog, and you can see kind of what we're doing here. As soon as the CD spins up. Hello? There we go. Autoplay. It's thinking about autoplaying. All right, we'll do this the hard way. It must be cursed this morning. Again, I did this right before I walked up on stage. Okay, so let's run SQL setup. Oh, there we go, finally. Install SQL Server. I'll install the desktop edition because all I have is an enterprise CD with me. Now this dialog is going to come up on every single install of SQL Server, even if you choose a typical setup, which is what we'll do here. So you cannot get around the security dialog. On Windows 2000 or NT4, it'll default to integrated. On Windows 95, or excuse me, Windows 98 or Windows Millennium, it'll default to mixed because we don't have integrated mode there. So I'm just going through a normal setup here. I'm going to install install. Do a typical setup, fine, use local system, and then you get this dialog. It says, what do you want to do? You want to go in Windows Authentication mode, which is the default. You just click Next to be in integrated security mode. If I go to mixed mode, it says, what password do you want for SA? And I could type some password. Or I could say, I want a blank password, and as you see, we say, not recommended, don't do that. But we'll let you do it. I mean, if you really want to, you can do it. But the default is going to be integrated mode now. So we want to get you in integrated mode and we want to lock everything down. Now, even if I choose mixed mode security, we'll still do the NTFS lockdown, we'll still do the registry key lockdowns. You cannot configure that. It just happens for you. Okay, let's go ahead and go back to the PowerPoint deck. So we think what we've done here is totally lock down SQL Server when you install it. We don't think we're going to have any issues here now with saying, well, you didn't really set up securely. Networking improvements. What have we done on the network? We've completely redone networking in SQL Server 2000. We now have, it's not really a network protocol, it's sort of a master protocol called SuperSockets. The SuperSockets network library is how we'll refer to it. And what we've done is via SuperSockets we were able to do a bunch of really nice things. For instance, we now enable SSL over the login attempts and potentially the data transfer back and forth from a client to SQL Server. We will always attempt to encrypt a standard security login, even if you don't ask us on the server or the client. If there's any way we can do it, we will attempt to get an encrypted connection. Optionally, we can encrypt your entire connection. So if you want us to, we could say all the traffic from this SQL Server client to any SQL Server on the network will always be encrypted. Now, we've also done the reverse, which is everybody who wants to talk to the SQL Server, I don't care who you are, you have to use encryption. We've also added full support for Kerberos and delegation support. So I can say add a linked server, and when I add the linked server, impersonate the person, and when I show up on the remote machine, I'll really still be me. There was a checkbox in 7, but basically I pulled that at the last minute in SQL 7 because Windows kept changing their mind about how they were implementing Kerberos, and I'm really glad I did because the implementation changed actually as late as RC3 of Windows 2000. But we work now, you can set it up, we've got it running in our labs, it's actually pretty nice, so I could say I am this user to IIS, IIS could delegate your credentials to a first SQL server, I could add a linked server, and then on the second SQL server, and so on and so on. I am really still me, which should make a Windows integrated login a much more viable solution for you now. I know one of the reasons you had to use standard is because you wanted to go across multiple machines or use linked servers. Now this is also very nice in our federated database approach, in our distributed partition views. You could use integrated security now because we can just impersonate across all the nodes of the cluster. There is a little bit of setup for setting up encryption over the network. The server has to have a public key certificate that the clients trust. So what you have to do is if you have a certificate architecture already in your company, You can get a certificate, and you have to make sure that when you request a certificate, you ask for a certificate for a particular machine, not for the user account of SQL Server. So I actually, for instance, on my laptop here, I had to request a certificate for rwaymire0.redmond.microsoft.com. Then if the clients don't automatically trust the certificate, you need to use the IE admin kit to add the certificate. If you're not interested in that, or you don't even know what the IE admin kit is, the easiest thing to do is go pay a couple $100 to VeriSign or Thought or one of the public key infrastructure companies out on the internet and get yourself a server certificate. And then basically you get in a mode of having to pay them for one. But if you're deploying Windows 2000 or you have NT4 with the option pack, you get certificate server. So you can build your own infrastructure or ask your network guys to do that. Do make sure that when you request a certificate, you do not use the NetBIOS name of your machine, you use the fully qualified DNS name of the machine. Once you have that, we'll always try and encrypt the standard security login handshake, so no more blank even usernames over the network, if we can do it. Now, none of this is necessary for integrated security login attempts because there's nothing going over the wire that's really dangerous. Again, optionally, I can say from this client, I always want to use encryption, but do be careful with that, because that means if you try and connect to a server that doesn't support encryption, it doesn't have a certificate assigned, you can't connect. So that's kind of a feature you have to watch out for. That's just a checkbox in the client network utility. If we can jump over to my laptop for a second, I can just show you that. So if we bring up the client network utility, let me kill some of these other things I got running here. Programs, SQL Server Tools, client network utility. You'll see this enable protocol encryption. That says every connection attempt I try and make now is going to be encrypted. So if I try and connect to my server, that connection is now encrypted because I have a certificate assigned to this server. Now, if I were to try and connect to some other server on the network, so let me see. No, I'm not connected to the network right now. So if I tried to connect to a server on the network that didn't support encryption, you'd get a nice, we actually for once give you a nice error message that says encryption not supported on this SQL server. We're trying to do better than SQL server is unavailable or does not exist. Now, back to the PowerPoint here. If the certificate is not trusted by the client, your connection attempt will fail. And here's where you see that message that you get back. Encryption is not supported on SQL Server. My favorite option for security in this release is the secure server option. I can force encryption on all communications with the server. What you do is you go into the server network utility, and there's the same checkbox that I just showed you on the client side, and you check it, and what it's going to do, it doesn't do it right now, which is why I'm not showing it to you, but what it's going to do for beta 2 is when you check it, it'll bring up a dialog box and ask you to pick which certificate you want to use. So the certificate you just went and got from VeriSign or Thought or your internal network people, you click on it and click OK. It'll now assign that certificate to SQL Server, and that'll be the one we negotiate encryption with. And basically, we're just going to store that in a registry key. Any connection attempt that cannot negotiate encryption is rejected. So you as a SQL Server administrator can be absolutely 100% guaranteed nobody is getting through an unencrypted connection. Now what that means is if I'm setting up an HR database or anything sensitive, maybe even for just a Joe website, but I'm transmitting people's credit card numbers, as an additional measure of security for the customer, you can say, I can guarantee you that all SQL Server communications are encrypted. I will never flow your credit card number or your username or anything over the network unencrypted. Now this will use this, the level of encryption that you have available on the client and the server. Now in Windows 2000 everything's 128-bit, and 128-bit is reasonably computationally secure today. If we start getting larger keys, we'll just work with them. All we do is just use the core services that Windows already provides for us. Kerberos, again, is fully supported in SQL Server 2000. As you probably know from the marketing drum of Microsoft, it's much more secure than NT LAN Manager, even NTLM version 2. And it does give you delegation, which again is this ability to bridge your security credentials across more than one server. In SQL Server 7.0, if you gave me security credentials, I could use them to impersonate you to go out and do things on the local computer. So if I came into this server's Redmond Waymire and wanted to access the file system, SQL Server could, at least in theory, impersonate you and then go out and try and access the file system. If I had IIS and SQL on the same machine, that's why it worked to pass your credentials in integrated security mode from IIS to SQL, because it's still on the same computer. But when you tried to leave the machine boundary, we lost your credentials and you show up on the remote computer as anonymous. In delegation mode, I show up here on my client, I log into server 1 sends my credentials to server 2. It's pretty cool, but it doesn't happen by default, let's put it that way. You have to be in a Windows 2000 domain. You have to be using Active Directory, and the client and server have to be using Kerberos. There can't be an NT4 domain controller anywhere in the way or none of this works. So all the computers involved, the domain controllers, your client computer, any of its domain controllers, and the server and any of its domain controllers have to be Windows 2000. So it might be a while before you can take advantage of this unless you're a very rapid early adopter of Windows 2000. Then you have to make friends with your Windows 2000 domain administrators, because what you need them to go in and do is make sure that they haven't set on any account that you want this to work for the option account is sensitive and cannot be delegated. And if you go look inside the Active Directory, you'll see that option available and you can go set that. The account is trusted for delegation option must be set. So an Active Directory administrator, you'll look at the user and check this little checkbox. And finally, the SQL Server computer has to be trusted for delegation. So you have to go into the computer management portion of Active Directory and set the option to trust the computer for delegation. Again, none of these things are necessarily set by default. So you have to have your domain administrator agree with you to set this up. There's a couple additional details that are absolutely essential. First of all, this only works over sockets. This is a TCP. The reason it only works that way is we actually target a particular port. One of the things that has to happen to make Kerberos secure is not only does the server agree who the client is, but the client has to agree that the server is really who they say they are. The way we do that in Windows 2000 is we have something called an SPN, a Service Principal Name, that a domain administrator assigns to a computer and to a service that says, this is really this service listening on this TCP IP port on this machine. If you run SQL Server with a domain user account, you have to add an SPN yourself. We don't have the right to do it. And in fact, in Windows 2000 by default, only domain administrators can add SPNs. That's your assurance that it's really real, as they require this extraordinary level of permissions. And it's probably unlikely your domain administrators will let you have the right to do that. You never know. Unfortunately, the only way to set an SPN is via a Windows 2000 Resource Kit utility called set SPN. They didn't get around to adding SPNs into the UI because SPNs basically came online extraordinarily late when they discovered that they needed to have these to make the whole network secure. What you do is you install the Windows 2000 Resource Kit, open up a command line, and say set SPN dash uppercase A MS SQL service. That's the name that we've been assigned in the world of Active Directory for SQL Server, / the name of the host computer running SQL Server, / the TCP IP port you want to set this up for. So an example, set SPN -A MS SQL service. Now notice it's the fully qualified domain name of my computer, Waymire Redmond Corp Microsoft.com, :1433. And then I'd forgotten to mention the service account. And then in this case, I'm running in a service account. In a pure Windows 2000 domain architecture, service account names are unique across your entire forest. So there can only be one Waymire anywhere. And in fact, if I tried to say Redmond /Waymire, the set SPN will fail. So I just have to provide Waymire. So just provide the name of the service. And then clients can use Kerberos to connect to you. If you haven't done this, it just won't work. And you'll start getting weird errors about NT authority /anonymous could not log in successfully. That's your clue that delegation isn't working correctly. Or if you want to go a little bit easier, for some reason in Windows they trust the computer accounts but not user accounts. So when SQL Server starts and it's running under local system actually has an identity in Windows 2000 and it has the right to add SPNs for itself. So if we start our service as local system, we will automatically register the appropriate SPN for you. And the SPNs are actually kept in the Active Directory. So when a client wants to talk to a server, it goes to Active Directory and fetches the SPN, and that's how it decides whether it's going to use Kerberos or NTLM to talk to that server. So a local system's a whole lot easier, but there are a few things that still don't work quite right under local system. Now, in a pure Windows 2000 environment, a lot of those features are actually working fine. For instance, you can go out over the network, even with local system, but only from a Windows 2000 computer to another Windows 2000 computer. If you try and go to NT4, it says, I don't know what you're talking about, and won't let it connect. So again, a lot of these features are really cool, but they only work in a pure Windows 2000 environment. All accounts that you want to use for delegation have to be in the same domain or within the same trust tree. So either a tree or a forest all have to trust each other for any of this to work, because they all have to be able to talk to the same Active Directory computers. Don't use dynamic TCP ports ever. Setup allows you to use dynamic TCP IP ports, but you have to register the SPN for it. Especially if you're using a service account, you want that SPN to be fixed. Part of the SPN is the TCP port number, so we have to have that fixed. And again, you have to start cooperating with your domain administrators if you want any of this to work for you. So that's what we've done on the network. We think this will make your life a lot easier to move to integrated security over time as you become a pure Windows 2000 shop from your environment. If you can't do that, we can still do the SSL stuff if you get a public key infrastructure. Server role enhancements. We've made some changes to how server roles work in SQL Server 2000 based on very passionate customer feedback. We've added a new role called bulk admin, so you don't have to be sysadmin to run bulk insert anymore. What you can do is add a login to the bulk admin fixed server role. This does not give you the right to just load anything. You still need insert permissions on the table you want to load, but now again you don't have to be the system administrator. Security admins can now change passwords of standard SQL Server users. That was something we didn't implement in SQL 7. But they can't change the password of a system administrator, otherwise they could become any system administrator. Server admin can control all aspects of messages. The implementation was a little bizarre in SQL 7. Some things worked, some things didn't. We cleaned that up. And in fact, we've cleaned up a tremendous amount in terms of fixed server roles. All of the rights you see reflected when you right-click on a login and say server roles in Enterprise Manager are correct now for what's actually implemented in SQL Server 2000. So maybe these aren't a big deal, but they're just trying to clean everything up. I can also tell you that, well, I'll get to that in C2. I'll jump ahead in just a minute. Miscellaneous other enhancements. We have full support for the Windows 2000 encrypted file system. So if you're really paranoid and don't want to take the chance that somebody could steal your SQL Server databases when you're shut down, you can encrypt them using the encrypted file system in NTFS. And we work with that. We're testing that just to make sure that we can't corrupt or anything like that. We're still testing that, but so far everything looks good. All of that is based on the crypto API. There were a number of sites that have announced that they've found interesting and varied ways to get the text of stored procedures, views, triggers, whatever, that you'd encrypted. There was another one that said they'd found a way to find linked server login passwords. Well, we don't want that to happen anymore, so we're using the crypto API to lock everything down inside of SQL Server, and it's going to be very, very secure. We used actually a combination of algorithms that we got from our crypto team inside of Microsoft. So we don't think we're going to see anybody saying, I can decrypt the text of your stored procs anymore. We don't think that'll happen. Don't want to issue any challenges because it's still just encryption, and ultimately, computationally, it can be broken eventually. But we don't think that's going to happen anytime soon. We eliminated the SUID column in all tables. In SQL Server 7, we didn't use the SUID column, but we did still have it all over the place. In SQL Server 2000, it's gone. It's gone from sys databases, sys logins, sys remote logins, sys users, and sys processes. Sys alternates doesn't exist anymore because its only purpose was to map SUIDs to other SUIDs, and we don't have SUIDs anymore. SUSER ID and SUSER name are still supported functions, but they always return null. So you won't get a syntax error if you called those supported functions. You'll just get a null result back now. So we're just cleaning up, basically, because SIDs are the only thing that matters for security in SQL Server 7 and 2000. We did a little bit of an enhancement to backup security. We password protect your backup media if you want to specify that now, and we can password protect backup sets so that you can't read them unless you know the password, and you can't restore them unless you know the password. So our tools will prevent that. NT tools by default will prevent that. but the data is not encrypted. So if somebody writes a tool to go around password-protected backups, just like you could go around a password-protected backup in NT if you wrote your own utility, that will work. So somebody could still get your stuff. But by default, you can at least password protect it so that only authorized administrators could perform a restore. So even if they got a hold of the restore tape or the restore file, they can't restore it without knowing the password you used to back it up. This also does not protect you against media overwrite. If somebody does a backup with init, even if there's a password on the old file, we'll wipe it out and dutifully put your new one down, just like we always did. I put this slide in here to talk just briefly about user-defined functions because their security is a little bit more complicated than most statements in SQL Server. First of all, we added a create function statement permission, so you can have the right to create a function. That part's actually pretty straightforward. If a function statement is schema bound, you need references permissions on any function, table, or view that you call. What we mean by schema bound is the function will start erroring out if you go change the DDL on it. So when you schema bind something in SQL Server 2000, it's protected to some extent from changes. References permissions can now be granted to views and functions because we needed it to support this schema binding concept. Invoking it is where it gets a little strange. If I invoke a function like I would have called a stored procedure, I call it as a scalar function, like select column 1, fn my function of column 2, then you need execute permissions on the function. If the function returns a table data type result set, and you call it as, like I was doing with my profiler traces, select star from : fn my function, then you need select permissions on the function because it's returning a result set. And hopefully that won't be too confusing. If you watched Talk 2-308, the Transact SQL Enhancements from Balaji Radhakrishnan, he went into a lot of the features of functions, and you can get more information from that talk or from those slides. So I do want to address the SQL Server 2000 C2 security evaluation, just kind of touch on it real quick. It is still ongoing. It won't obviously be able to be finished until we ship the product, but we are trying very hard for a US government C2 rating. That C2 rating would be on a C2 compliant operating system, which is NT4 SP6 with a hotfix, and on a particular kind of hardware. There's a lot of restrictions to be truly C2 compliant. Now we're doing this to help out the federal team because most government contracts require that your SQL Server or your database rather be C2 compliant. To do this, it's driven a number of changes like the re-architecting and re-implementation of Profiler, the addition of auditing, and I did want to mention that we have dramatically ramped up our security testing. Now, certainly we did security testing before, but now we're doing just, almost ridiculous amounts of security testing. We've written over 1,000 new tests just to check every possible aspect of security in SQL Server, and we continue to write new tests. We're working on just total test coverage, and that again is required for C2. So I think your confidence level in our security can go up very much in SQL Server 2000. I think we did a good job in 7.0, but there's more we can do, and we're doing it. So there are security enhancements throughout the product. We want to provide you a secure setup on NT or Windows 2000. It just works, it locks everything down, and you're safe and secure. Network level security has been greatly enhanced via the SSL and Kerberos implementations. And again, just lots of miscellaneous things here and there. The new fixed server role, the addition of a couple rights to the server roles, the cleanup of the documentation, and all around we're trying to support all of the security features of Windows 2000. So with that, we'll take questions. Over here, please.
Hello?
There you go.
I have a couple of questions, please, for you. First, the IIS team always recommend to use the TCP/IP over.
Can you speak a little bit louder? I'm having a hard time hearing you.
Yeah. The IIS team always recommend to use TCP/IP over named pipes.
Yes.
And the problem with the SQL 6.5 was that TCP/IP wasn't. We weren't able to use it along with integrated security, right?
That's correct.
Hopefully now we can both use TCP/IP and integrated security.
In SQL Server 7 and 2000, every network library supports an integrated security connection.
Thanks. Also, I don't know how in Windows 2000 now things work, but in NT4, the domain admin group is automatically included in every local administrator's machine.
That's still true in Windows 2000.
Okay, so I used to like not to grant SA permissions to that local administrators because I don't want the network administrators to fool around and be SA.
Okay.
So can I still remove the built-in administrators group in SQL 7 or 2000?
You can, but I would recommend a different approach, which would be grant login rights or leave the grant login rights alone for built-in administrators, and if you want to explicitly deny them, go in and put a deny record for the domain administrators. So, and we will then deny NT administrators from the domain, but permit local administrators who aren't also domain administrators from coming in. So if you were the administrator of a box but weren't the NT domain admin, in that scenario, you'd still be allowed to connect with integrated security, but your NT domain administrators would not.
Okay. Again, you said that the SUID column disappeared from the system tables.
That's correct.
I'm using it a lot in my scripts, so is there anything for replacing or what?
It doesn't mean anything in SQL Server 2000, and using it could actually lead you to incorrect results, which is why we eliminated it. We found some of our customers were still thinking SUID had some meaning in any of our system tables, and it doesn't. And in fact, we can't even guarantee that the SUID it's a dynamically generated column in the syslogins view. We can't even guarantee that we'll generate the same one every time. So that's why we pulled it. It just is not reliable, and it doesn't mean anything, and we never use it internally. So that's probably going to be a little bit of pain upgrading, but I think you'll be better off for it.
So in my script, how will I link all these tables? Well, you said
everywhere you refer to SUID, you have to change it to SID.
To what? Excuse me?
To SID.
Okay.
Which is a var binary 85 value instead of an integer.
Thanks so much.
Chris.
I've just got a handful of what I hope are short questions. First, you mentioned that the setup program will update NTFS permissions on the whole SQL tree based on the service account. If I later change the service account in Enterprise Manager, will that update? Or is that a setup program only?
It does not. Would you do me a huge favor and send me that in email, and I'll make sure it does for beta 2.
Thank you. Sure.
That's a good point. Thank you.
That's Tiber's. Next quick request, can you enhance the books online description of the fixed roles? There's like a one-line blurb now, and it's not very clear as to the distinction between the roles.
We've worked a lot on all of the security sections of the books online. Okay. For instance, in SQL 7, you may have noticed that sometimes the permissions in the books online don't necessarily line up with what's really there. As part of our overall C2 effort, we're making sure that the documentation lines up with what actually happens, which lines up with what shows up in Enterprise Manager. And so you should not be able to find a documentation bug in terms of what rights are required. And we've gone through very meticulously through the books online and actually had a tester run every single command with every single option turned on or off and tried it and to see exactly what the permissions that are actually enforced in code are as opposed to what we thought we were, and then either fix the code or fix the documentation.
Okay. Last one. Not in SQL 2000, but later you say standard security goes away.
Yep.
There are a lot of web apps out there that need to use basic authentication because the client's using Netscape or something else.
Sure.
What are we going to do?
I have a wonderful answer for you. IIS has the ability to map either a basic auth connection or a public key certificate into an NT user account now in IIS 2000. So with IIS 5 2000, you can take care of that. And in fact, I'll put in a little plug here. A guy named Michael Howard at Microsoft, myself, and another guy named Mark Levy, who is the ComPlus security PM, are in the process of just finishing up a book on describing exactly how to make that configuration work, even with Netscape clients doing basic auth, and have Kerberos flow all the way through to the SQL servers. And we discuss all of these options and exactly step by step what you need to do to turn them on or off, and show you code samples, the whole bit. to make all that work.
Thanks.
Which reminds me, I actually wanted Dan Meacham. Dan, are you around? I wanted you to come on up too. Dan is taking, I want him to take a couple questions with me if we can. He's transitioning into the role of owning security on the server, and then I own security sort of for the whole product. So I wanted to have Dan up here as well. We'll take the next question.
Yeah, right now with SQL 7, a user submits a job, and the job's owned by the SQL agent command exec account.
Yes.
Oh. Yeah, I was hoping you would address this so we wouldn't have to ask it. If the job needs to write to a remote system, the SQL agent command exec account, of course, is local to the server that initiated the job. And so if it needs to write, we need to do something to...
So one of the things we haven't done, I understand the point completely.
Yeah.
One of the things we haven't done, but we're still looking at doing potentially for beta 2, is to let you specify which account to use rather than always using the account we add. And then you could say, no, really, whenever you want to leave SQL Server, use XYZ domain account instead of this local user account.
When you submit the job, allow it to use a different account?
That's what we're trying to do,
That's
yeah.
what you're trying to do?
But
yeah, something needs to be done.
yeah, it's non-trivial, and I'll tell you why. And the answer is, in order to do that log, well, I mean, it's non-trivial, and we're working on it. And I won't bore you with all the details. We're trying to make it work for beta 2. And hopefully we'll have a solution.
Well, I don't care about beta 2. I care about RTM.
Right. But we're working on it.
I had just another question. I was just curious. Why do you still give the option for the blank password? Why don't you just eliminate it altogether?
Well, should I tell you the truth?
Yeah, sure.
Okay. Because a lot of our test scripts inside of the SQL team still depend on SA no password. And because
shame on you.
Yeah, I know. And I'm fixing that. I'm changing people to integrated, but it's like Paul said, there's like 20,000 tests or something. It takes time to modify all those scripts.
You had made a comment earlier that you felt that SQL Server was fully secure now, and that's one place, I guess, I could see folks that I work with using that, and it isn't fully secure as long as you give that option.
But and then you have to, if you want to take that all the way, then I have to go in and modify the source of SP password to always check for null passwords or for blank passwords. And you can take this to extremes. If somebody wants to do something stupid, I'm probably going to let them still at some point. In T, for instance, will still let you set a blank administrator password. They tell you never to do that, but you can still do it. I would never ever do that in a production environment, but I do see, for instance, on a test system where nobody's caring about security, we're just trying to get development done, where SA no password is a habit, and people might still want to do that. I agree on a production system it should never be done, but I've gotten strong feedback that people still want to be able to set a blank password, as well as our own test team, but we're fixing those guys. But
I'd like to see it not be quite so easy.
Okay.
Thank you.
Thanks for the feedback. Start over here again.
Okay. In the Enterprise Manager, if you're using the trusted or the secure server mode,
Yes.
and can you use the Enterprise Manager actually accept a certificate from a non-trusted root on the fly?
Okay. Can you do that? No, we actually use the certificate infrastructure provided by IIS and by Internet Explorer. So in your machine, you have certificates stored. What you could do is if it didn't work, and you could then, if somebody emailed you a certificate, you could add that certificate to your local trusted store. Can we switch over to my laptop for a minute? I'll show you just real quickly what I'm talking about here. Okay, so I have a certificate up here called test root certificate that we use in some internal testing. When I right click on that, I can say install this certificate. And it says welcome to the import wizard. You click next. I can place this in a certificate store on my system. This is a certificate that I want to trust so that it just automatically trusts it. So I put it in the trusted root certificate authority, and I can install it on my local computer. I click OK, click next, finish, and it imports that certificate. From now on, anybody who's got a certificate from that certificate authority will be allowed to to trust that certificate. So now my server can have a certificate issued by those guys, and my client will trust it. And so what that did is import it into Internet Explorer. Let me see. So tools, Internet options, security. No, it's I can never remember. They hide it in the wrong place. Content, certificates. And what you can see, for instance, is there's my certificate that was issued. If you notice there, it's to rwaymire0.redmond.corp.microsoft.com, and it is intended to identify a computer. And so this is the kind of certificate you need for SQL Server. And then this was issued by our internal certificate implementation inside of Microsoft. You can see I've got other keys out here, like I've got a VeriSign certificate to prove my email identity if I wanted to encrypt that. So you have to make sure you don't get one of these kind of certificates. You have to get a certificate for the computer. And once you've added that, it should instantaneously take effect. And then all of a sudden Enterprise Manager or whatever else will work. And it doesn't really matter what the tool is. It's not just our tools that obey this, it's any application. We implemented this at the network library layer. So any application on that system using ODBC, OLADB, or DB Live should be forced to do the encryption.
That's right. The other question was on the Kerberos delegation, how much sort of cross-vendor integration or testing be done with that?
How much what?
Is that, will that work with other vendors' Kerberos products?
And we do interop with some Unix Kerberos implementations and MIT implementations. And in fact, there's a white paper up on the www.microsoft.com/Windows site on Kerberos interop. I think it went up in just the last few days. I reviewed a beta copy of it about a month ago. And it talks about some of the issues we have with interoping with an MIT or Unix Kerberos implementation. But basically, from our perspective, we'll always go to our domain controller, but if you've set up a trust relationship between the Kerberos implementations on the Windows 2000 domain controller and, say, your Unix implementation, it should transitively pass the ticket request onto the Unix system and then pass the permission back down to us.
Okay, thanks.
You're welcome.
This has to do with like security and ease of maintenance. In SQL 7, if you wanted to, many companies will hire a big group of people, set up their usernames before they come in, but some of those people may never show up, so they never actually log into the SQL Server database. Now, how do you find those and eliminate them so that your database users are a clean set? Previously, the only answer I've ever been able to get is you run a trace on this, a profiler trace on the server, and catch logons, but that never catches people that never log on.
Right. And the answer to that is that in the sysx login system table, there is a column called date last logged in or something, and we populate that when you connect. And if that column's blank or it has like January 1st, 1900 or something in it, that means they've never logged in. And I'm going to do a plug for a third-party product here. There's a product, in fact, Dan, why don't you talk about it since you've done a bunch of work with it recently.
I was going to suggest that you can use the ISS, is it? ISS database?
ISS, yep.
And effectively what you do is you set up a profile to your security level using this database scanner software, and it searches through your server and detects, it reports back to you where there are security weaknesses and where you should sort of evaluate whether or not this is a good idea. And one of the features of this is whether users log on regularly. If users haven't logged on, say they're idle users, it recommends, hey, watch out, remove this guy. So that's a pretty good product.
What was the name of that table again?
sysx logins in master. But you can download an evaluation copy of the database scanner product from our website. We have a link to it, or from www.iss.net. Either way, and it goes through and looks for things like we were being asked about a few minutes ago about null SA passwords. It does all kinds of checks. It checks the initial text of every stored proc against the text from our install directory to see if somebody's modified your system procs. It does a lot of interesting things.
Thank you.
My question is, I think it's very closely related to the woman that was before me. I understand that that all SQL Server agent jobs run in the context of the account that you've set in the properties for the SQL Server agent. Is that correct?
Yes, it's run into the, if you're a system administrator, it's run into the context of the service account. If you're not a system administrator, it runs in either your standard security context of the job owner or the NT security context of the job owner within SQL Server only. It doesn't leave the network with the security credentials of the NT user. The only way to do that would be to have a batch login, and the Windows team is looking at adding a batch login service that would securely store your password so that we could then log you in and have the right to log you in. They're building a whole infrastructure for that in a future version of Windows, and we've requested it specifically to support SQL Agent.
Oh, so that's better than what I thought it was. So if all you need is access to resources within that server, then you can just set the owner of the job, that particular job, to an owner that has the appropriate
Permissions within
permissions.
SQL Server, and then we'll impersonate that user within the server. That's correct.
Okay. And so the only problem is when you need access to resources that are in the domain outside of
That's
the
correct,
server.
and we're not allowing that specifically because you didn't do a real login, because then we'd essentially have to find a way to log you in without your password, which we don't have. And then we looked at how to do that, to find a way around that, like having you type in your password when you create the job. And we got into, then we start storing your password, and you have to question how secure that is, so we'd have to write it to LSA secrets. And basically we're starting to do part of the job of the operating system. We went down this path with the NT security team, and they agreed we just shouldn't go there, and they should build the infrastructure to do that for us. So like I said, in a future release of Windows, they're going to have a batch login service that essentially will, when you want to create a batch job, which is basically what an agent task is, you would set up the batch job, type your real domain credentials, including your password. It will store it securely, and then when the job starts, it does a real NT login for you, and then you could go anywhere on the network because you're really you, and anything you could do, that batch job could do.
Yeah. It's important because, well, batch job, the job scheduling is very important to production applications.
Yeah, I agree. It's been a weakness in the Windows family for a while, and we are starting to pay a lot more attention to things like batch production jobs. Back over here?
Okay. Can you hear me okay?
Yep.
On the topic of enabling delegation, you were mentioning that there's a command set SPN, and you gave the syntax.
Yep.
One of the parameters you mentioned was the host, and you said to make sure you use the fully qualified domain name.
That's correct.
My question is, if I'm using a clustered server, is that going to be supported? Do I get a fully qualified domain name for a virtual server?
Yes. So what you would set is whatever, both of the computers in the cluster have to be in the same domain. So you'd find what you do is you look at one of the computers in the cluster, like if it was server1.corp.microsoft.com and server 2, then when you created the cluster as RW cluster, the SPN would be for rwcluster.corp.microsoft.com. And so yes, we support it on virtual servers. Again, only with TCP/IP sockets.
Okay. All right.
Great. Yeah, I'm on a jihad for clustering. I make sure it works on the cluster. Bob.
Richard, you mentioned in the talk about the overhead of a profiler trace, especially with auditing. If you've got a government client, have you guys done any benchmarking on the performance yet, running an audit or the profiler?
We are going to have, before we ship, fully audited statements in our product that say if you turn on C2 auditing, you're going to have X percentage overhead when running a benchmark with this server this busy and those sorts of things. Because we completely re-architected the profiler between beta 1 and beta 2, it's not quite cooked yet. So we're not at the stage where we can run performance tests. But before we ship, we will. And we'll make statements about the overhead. I know that some clients say you can't have auditing that uses more than X percent of the server, like 3 or 5% or whatever. And we're aggressively targeting goals of being less than some percentage of overhead, and we'd like to keep that very small, but we haven't measured it yet. But we certainly will, and there will be statements in the books online about the overhead to expect for an audit trace. I don't think we are going to also do that for the black box that I talked about, but I don't think we're going to do it for the general case of profiler. There's just too many. The matrix is just unbelievably complex on the things you could do and how much data you could collect, and then you start asking questions like, well, what drive does it go to? Did I isolate it? How fast was my SCSI subsystem on that drive? It's a real mess. But we are going to try and come out with some measurements to help give you guides so that you know how to deploy it better.
Great, thanks.
Like my MTS components to impersonate, pass through the security identifier of the client down to SQL Server. But if I do that, the connection pooling doesn't perform very well.
That's correct. In fact, it doesn't work.
So is there going to be any workaround for that? Is that going to be the
Not
same?
not in terms of connection pooling, but object pooling will still work. So object reuse in the COM Plus layer in Windows 2000 will still work, which is another new feature of COM Plus in Windows 2000, but connection pooling won't. So you'll still have the overhead of making a new connection to SQL every time. So that's a big trade-off you have to make. Do I want to know who they really are at the database level, or do I want to implement my security in the middle tier and just come in as the MTS account into SQL Server? That's, again, one of those core trade-offs you have to make when deciding how to do in-tier security. Kerberos is not always the right answer. We're just finally giving you the option to make it viable.
Okay, my second question isn't really a question, it's a complaint. In the labs here, SA with blank password is always used, and I tried using it, using NT integrated authentication, and most of them worked. All the ones that I tried did work. So I'd like you to encourage the people who write those things to not make us put in SA and password. It's a lot, they go a lot faster if you don't do that. And once you start getting SA and any password in your code for testing, that's going to migrate into your production apps by mistake.
Yep.
So I'd like everybody in Microsoft to get away from using that wherever possible.
Yep, and in fact, we are getting to religion. There are two issues there. Number one, the books online, all the examples that show SA no password are being modified as we speak to use /e on OSQL, so that they will make a trusted connection. I'm working very hard. That's a big change for those guys to make, just a lot of change, but we're working on doing exactly that so our examples don't show security holes, basically. And the second thing is that the only excuse I can make for the lab is they're using a build before we integrated the security dialog. The security dialog only went in about 5 days ago into setup. So those systems, when you set them up, they were SA no password. So if there's any defense for them, that would be it. That they'd have had to go through to all 60 machines and change them to integrated security and restart. They could have done that, you're absolutely right.
But they're mixed security, so it works.
Right.
I mean, it works already. Even if they have a blank password, they could have a blank password, but not have that as
no,
part of the requirement.
I understand the point. Changing, in a sense, we're trying to change the beginnings of a corporate culture here, that people have been, I mean, since SQL Server 4 is when I was a user and first started doing SQL Server on up, and a lot of the people on the team have been using SQL Server even longer than that. They go back to the OS2 days. They've been logging /USA/P, and it's just habit. And we're beating it out of people to say no, use integrated security, but it is a big change for folks. And one of the things that I'm trying to drive through, and our whole team is trying to drive through, and just to make that change and say, look, you know, the right thing to do here is to do what we tell our customers to do. So we're locking down everything, we're using integrated security, and we're changing pieces one at a time here, like I said, the documentation and whatever else, to reflect that. And so I will bring that back to our marketing team who put together the lab. That's a good point.
One more question, Richard.
All right, Ron?
Richard, back to a short question on auditing. I think this is possible. I just wanted confirmation. Could you select a subset of the objects of a database, like a few tables, and have it audit both the DML and the DDL? So both select, you know, rather insert, update, and delete, and alter table, or?
Yes, absolutely. Any level of filtering that can be done with the profiler can be done in an audit trace. So
excellent. Thank
completely supported. All right, we'll take the rest of the questions up at the bottom of the stage here. Thank you very much.